Today we're going to be studying proportional relationships. You might be asking yourself when you hear the word relationship between who? Or relationship between what? That's an excellent question to ask. We're talking about the relationship between X and Y. How are they related? In 7th grade and beyond, you're going to be studying relationships between variables. You're going to be asked, is this relationship proportional, non-proportional, linear, nonlinear, quadratic, exponential? This year in 7th grade, we're going to be focusing on proportional relationships and understanding what makes a relationship proportional or not proportional. So today, I'm hoping that in this video, we'll get a look at what a proportional relationship will look like in a graph, in a table, and when you look at it in equation form. Let's start with the equation. A proportional equation looks like this. Y equals kx. It's very simple. The k is the unit rate. K is the unit rate. You can also say that k is the constant of proportionality. These are both names for k. On the EOG, they might say, find the constant of proportionality, or find the unit rate, and you'll have to know that both of those refer back to k. The equation I chose for us to graph today is y equals 3x. And you'll notice that this 3 is in the spot where k is. So that means that 3 is k. It means that 3 is the unit rate. It also means that 3 is the constant of proportionality. And now what we're going to do is we're going to focus on the table. In the table, you should see that neither is labeled with x or y, and that's because we're expected to know that x goes in the left column and y is the right column. This is how it's going to be in any math book, on the EOG, on the SAT that you might take as you're looking towards moving to college. So just remember that x is always on the left, y is always on the right. Now that we've established that, what I'm going to do is I'm just going to choose an x value. Let's start with 3. And then what I'm going to do is I'm going to come over to my equation and I'm going to replace x with what I chose x to be. I chose x to be 3. And then I'm going to go ahead and multiply because 3 is being multiplied by x, so 3 is being multiplied by 3, and I get 9 for my y value. We know that this is multiplication because the unit rate is always the coefficient, and a coefficient is being multiplied by the variable. Since we have our first point, I would like to go over and graph it on this coordinate plane. Remember that x is the horizontal line and y is this vertical line. And we call this the x-axis and we call this the y-axis. Now it's important to notice that the x-axis is the horizontal line, and on the end you have an arrow to the right, and on this end you have an arrow to the left, because the x-axis controls the horizontal movement. The y-axis controls the vertical movement, the up and down movement. If you forget, just look at the y-axis. You can see an arrow up and you can see an arrow down. We need to remember that to the right we have our positive values, so 1, 2, 3, and to the left we have negative values. Upwards, positive values, and downwards, negative values. Just like when we look at a number line when it's not in a coordinate plane. You know, for years you've been looking at a simple number line like this, or maybe on its own you looked at just a vertical number line on its own like this. This is just, two number lines combined. So now we're going to graph 3, 9. So we start on the x-axis. So I start at the origin 0, 0, and I'm going to move to the right 3. You don't start counting at 0. You don't count until you've moved over 1 square. So I would count 1 when I get to this first gray line, 2 when I get to the second gray line, and 3 when I get to the third gray line. Then I need to deal with this 9. And 9 is positive, so I'm going to be moving upwards. So I'm going to go back to here, 1, 2, 3, where I was, and then I'm going to move up 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to mark my point. So both the 3 and the 9 together told me where to put my coordinate. Now I'm going to choose a different color so you can clearly see which point I'm graphing. So now I'm going to choose a different value for x. I'm going to choose the number 2. I'll go over to my equation. I'm going to replace x with parentheses, and then inside those parentheses, I'm going to place the 2. I chose 2 for my next x value. 3 times 2 gives me 6. So when x is 2, y equals, oh, that doesn't look like a 6. That looks better, 6. So for y, I plug in a 6. This is my next coordinate, 2, 6. So I count to the right, 1, 2, and then upwards, 1, 2, 3, 4, 5, 6. All right, I switch colors again. And I'm going to choose 1 for my x value. I rewrite my equation. I'm going to put parentheses in for x because I'm going to replace x with 1. When you replace a variable with a number, that's called substitution. 3 times 1 gives me 3. So when x is 1, y is 3. Let's graph 1, 3. So positive 1, I move to the right 1 on the x-axis, and then I move upwards 1, 2, 3, and I mark that point. Time for a new color. And I'm going to use 0 for x now. So again, I'm hoping that you're paying attention to how I'm doing this so you're ready to do the next problem on your own. So I replace x with 0. 3 times 0 is equal to 0. So when x is 0, y is also 0. All right, to mark 0, 0, I go 0 left or right, so I don't go anywhere, and I go 0 up or down, so I didn't go anywhere. So 0, 0 is marked right here in the very middle, and this is also called the origin. New color. All right, y equals 3x. I'm going to choose a negative number this time. Let's use negative 1. So I replace x with negative 1, and I know this is going to be new to you, so don't freak out. I'm just going to tell you the answer. Positive times a negative gives you a negative. We get negative 3. So when x is negative 1, y is negative 3. Now, this is brand new. We haven't moved to the left yet, but since this is a negative 1, we need to move towards the negative direction. So I move to the left 1, and then for my y value, I have to move down. So I move to the left 1 and then down 1, 2, 3. So negative 1, negative 3, and I mark my point. And then we just have one more left. So what color have I not used? I haven't used this color. So I'm going to use negative 2 for my next value for x. So I replace x with parentheses, and then inside those parentheses I place my negative 2, and then a positive multiplied by a negative is a negative, so I get negative 6. So I place negative 6 in for y, and then I graph negative 1, 2, and then I go down 6. 1, 2, 3, 4, 5, 6. And now I'm ready to draw my line. So I'm going to choose a different color, and then I'm going to go to line, and I'm going to carefully click on this final coordinate point, and then I'm going to drag upwards to this point up here. I'm going to go a little past it actually. And then I'm going to go back to the scribble and draw an arrow on each end to show that this line goes on forever. And now we can start talking about what a proportional relationship looks like in a graph. Look, it's a straight line that goes through 0, 0. That's what a proportional relationship looks like when you graph it. When you look at the equation, it's a simple equation like this, y equals kx. That's what a proportional equation looks like. And then when you look at the table, I'd like you to actually pause it here and think about what a proportional relationship looks like in a table. What pattern do you see? What do you notice? So pause. All right, I hope you actually took the time to pause the video, and now let's talk about a relationship that you might have seen. How do you get from 3 to 9? How do you get from 2 to 6? How do you get from 1 to 3? Well, you multiply by 3. 3 times 3 gives you 9. 2 times 3 gives you 6. 1 times 3 gives you 3. 0 times 3 gives you 0. Negative 1 times 3 gives you negative 3. Negative 2 times 3 gives you negative 6. And guess what? That's a special number. Didn't we say that 3 was the unit rate, the constant of proportionality? So when you have a table that is proportional, you're going to be able to multiply every x value by the unit rate to get the y value. The other thing I want you to notice, let me grab another color for this, is that let's say that I grab this coordinate point. Okay, so I'm looking at the coordinate point 9, 3, and I'm going to write it as a fraction. 9, 3. And then on the other side, I'm going to grab another point. Let's grab 3, 1. So we got to make sure that the y's are across from the y's. So the 3 is a y, and the x is a 1. And I want you to notice something. This fraction, 9 to 3, is the same as this fraction, 3 to 1. Think about it. 9 divided by 3 gives you 3. This is scaling. 3 divided by 3 equals 1. So if you reduce 9 over 3, you get 3 over 1. And 3 divided by 1 is equal to 3, which is our unit rate, our constant of proportionality. So the other thing that you'll see in the table is the fact that each set of fractions is equivalent, because we talked about we're looking in this video at proportional relationships. So it just makes sense that these fractions would form a proportion. Remember, a proportion is when you have two equal fractions. So I hope that gave you a good little intro into what a proportional relationship is, what it looks like when x and y are in a proportional relationship.